Hello students, today we are going to discuss about another content of this unit 1, that is a non-concurrent force system, Vergnon's theorem, couple, its moment and many things. So today's lecture is very important related to non-concurrent force system. As we have discussed, what is non-concurrent forces? Till today we have discussed about the force resolution by using law of parallelogram, by using skew resolution, by using simple resolution of concurrent forces. Now, how to calculate the resultant of non-concurrent forces? What is the basic difference between concurrent and non-concurrent forces? Concurrent forces are passing through one point. They are meeting at one point. Now, non-concurrent forces are not passing through one point. They are acting at different points. That is called as the non-concurrent force system or non-concurrent forces. In non-concurrent forces, one thing is more important, that is moment of a force. Already we have discussed moment of a force in one of the lecture. So moment means what? It is the product of magnitude of force and perpendicular distance between the line of action of force and the given point. Okay, suppose this force is F here. If I want to take moment about this point A, so I will take moment of this force. This is the line of action of force, this one. And if I take moment about this A point, F into X, that will be the moment. And moment has a unit, Newton meter, Newton centimeter, Newton mm. And you know that moment causes rotatory effect on the body. So here this moment will be F into X. It is rotating anti-clockwise about A. So anti-clockwise moment we are going to take it as a positive. And clockwise moment we are going to take it as a negative. So here I have shown that force like this, vertically downward. F I have shown vertically downward. When I am showing this force here, about A, it will rotate clockwise. It will rotate clockwise. That's why here I have shown clockwise rotation. Here I have shown anti-clockwise rotation. So clockwise rotations are always negative, anti-clockwise are positive. So these are the standard sign convention as per the book Baer and Johnson. So that's why we are going to follow the same sign conventions here. So moment of a force along its line of action is 0. What it means? Moment of a force about its line of action is 0. If this force is acting here and if we are taking moment about the same point on its line of action, that moment will be 0. Okay. Now see sample problem here to take the moment about point O. If I want to take moment about point O, forces are 10 Newton, 20 Newton, 10 Newton. These are vertically upward, this one force is vertically downward. If I want to take moment about O, so moment means what? Force into perpendicular distance. So I must know magnitude of the force, that is 10 Newton is known, and perpendicular distance between the given force, line of action of given force. This is the line of action of 10 into perpendicular distance is 2. So about O, it will rotate in the anti-clockwise way, and its moment about O will be 10 into 2, and it is anti-clockwise, so positive. Similarly 20, line of action of 20 is this one, and perpendicular distance from O is 2 plus 2, 4, is plus 20 into 4. Why plus? Because it is also rotating anti-clockwise about point O. And then I have taken minus 10 into 6. This is the 10 kilonewton force acting vertically downward, and distance from O point is 2 plus 2 plus 2, that is 6 meter. About O, it will rotate in a clockwise direction. Okay, by maintaining same distance of 6 meter, this force will rotate like this. So it is a clockwise rotation. That's why I have written here over here negative 10 into 6. So total addition will be 10 into 220 plus 20 into 480, 80 plus 20 100, 100 minus this 60, it will be minus 40 Newton meter. Okay, so I think 20 plus 4, 80 plus 20, 80 plus 20, 100, 100 minus 60, 40. 100 minus this 60 means 40, and my bigger magnitude is this positive, it is not negative, because it is positive. This addition 20 plus 4 is 80 plus 20, 100 minus 60, 40, so it will be plus 40. So here I have made one mistake here. So please correct it. It must be plus 40, 40 Newton meter, and 40 indicates it is acting anti-clockwise. No, it is not a clockwise here. Make correction this one. It is anti-clockwise. Okay. If it is negative, then it is. If it is positive, then must be anti-clockwise. If it is negative, must be clockwise. Now see the second force. So what I did here. So I have shown one force intentionally inclined here. I want to take moment of this 10 Newton which is inclined at 30 degree with this line OA, and I want to take moment of this 10 Newton about O point. So first step, whenever any force is inclined, you must make it into two component, or you have to split up into two component from the point of application. So it is acting at point A. Okay. So it is acting at point A. So this 10 Newton will be resolved into two components, 10 cos of 30 in this way. This is the orientation is in second quadrant, so x component, y component. So it is acting at point A, so 10 cos of 30 will act here and 10 sin of 30 will act here. Okay. And then if you want to take moment about O point, what will happen here? So we have just seen here. So this moment of a force on its line of action is equal to 0. So how it will be 0? So 10 cos of 30, it is acting along line OA, means its line of action is also along line OA. This force is 10 cos of 30 along line OA, its line of action is also along line OA. So 10 cos of 30 into moment के लिए क्या होना चाहिए, perpendicular distance from O point. So what happened here? It is acting on the same line, means its perpendicular distance is 0. So it will cause a 0 moment about O point, which force 10 cos of 30. So this 10 cos of 30 into 0. Okay, moment about O. But you can see the second force. This is the line of action of this 10 sine of 30. This 10 sine of 30, this is the line of action, and perpendicular distance from O point from this line of action is 2 meter. And about O, it will rotate in anti-clockwise direction. So 10 sine of 30, it is the magnitude into perpendicular distance is 2. So 10 sine of 30 into 2, you will get 10 Newton meter. Sine 30, I think it is zero point 0.5. So zero point 0.5 into this 10 is 5, 5 into 2, 10, 10 Newton meter. And as it is positive, so it will be anti-clockwise. So in this way, you should take moment of forces. Now next important point is couple. Couple is slightly different from moment. Moment is a product of force and perpendicular distance. Okay, where resultant is not zero, but in couple resultant of the forces is zero. Couple means what? Equal and opposite. Two equal forces opposite in magnitude. Sorry, two equal forces having same magnitude. Okay. Unlike parallel means what? Opposite in direction are acting on the body, then that they are called as a couple. Okay, couple produces rotational effect on the body. See, if this force is rotated about this, it will rotate like this. If this is Q rotate about P, it will rotate like this. So this is the rotationary effect. Okay, so in a simple way, how we will define couple? To equal in magnitude, opposite in direction, parallel to each other forces forms a couple. Okay, simple definition. Equal in magnitude means P and Q must be have same magnitude. They must have same magnitude. Okay, and clockwise couple, again sign convention will be same. Clockwise couple negative, anti-clockwise will be negative, anti-clockwise will be positive. And here important properties of the couple are: the resultant of the couple is 0 because two equal forces are there. Okay, if this P is 10, Q must be 10 to form the couple. So 10 10, one is in this direction, another is in this direction, so resultant of couple is 0. That is an important property of the couple. To form a couple, two forces must be equal in magnitude and unlike parallel. It is also another property. Moment of a couple is equal to one of the force and arm of the couple. Arm means what? Perpendicular distance. A number of couples can be added algebraically. Okay, couple can be added algebraically. Means this, suppose this is one of the couple. Considering algebraically means what? Considering their signs. If this one is a clockwise, means you should take it as a negative. If another couple is there that is anti-clockwise, you should take it as positive, like that. Okay, couple, another property is couple can be balanced by another couple of same magnitude opposite in direction, that can be balanced. And what are the examples of couple in actual practice? So here, first example is paddling of cycle. Okay, so cycle has two pedals. So you should apply equal and opposite force, then they will rotate. Again, simple example of widening of a key of buzzer clock. Okay, you might have come across the older clock where they are normally used for the buzzer purpose. Okay, alarm clock. So they are having the key on the back side. Okay, so that key you have to how you are holding the key. Whenever you are tightening or winding that key, so at that time you have to apply equal and opposite force by using the our fingers. Even weighing balance by vegetable vendor. Okay, if you put the weight in one of the side, another will go up. When you will put weight in uh, above part, it will move down and it will move up. Means that moment is equal and opposite. Okay, one side goes up, and when we are balancing it, it shows that two equal magnitudes are same. But here weighing balance means what? Whenever you are adding weight on one side and another side is empty, okay, it should not be like that. Okay, so there should be weights in two directions. Okay, that is also one of the example of couple. Then resultant of parallel forces. So these are all those non-concurrent force system. That's why we are discussing here. Okay, so parallel forces. How to calculate resultant of this? You should take Fy equal to 0, or first forces in y direction should be added, because these forces are vertical. They may be horizontal like this. Okay, so resultant of parallel forces can be obtained by adding all the forces algebraically. Algebraically means what? Considering their direction, upward positive, downward negative, like that. Okay, so here you can see in the figure, upward I am going to take positive, downward I am going to take negative. So resultant of this force system R will be equal to plus 10 plus 20 minus 10 equal to 0. So plus minus 10 will cancel, and here we will get resultant R is 20 Newton upward, because direction of positive is more, so upward. Okay, so this is called as resultant of parallel forces. Now sometimes what is the important to locate that resultant in between this particular O to this last force. Okay, R we have calculated, that is simple, no problem. But where this R lies in this particular system, where this R lies in this particular system. Okay, so suppose here I want to instead of these three forces I want to show one single force 20 Newton, but where it will lie, that location of resultant will be decided by Varignon's theorem. Means to find the location of resultant, I must use Varignon's theorem. What is Varignon's theorem here? Here you can see here magnitude and direction of resultant is known, but the position where the resultant R is acting, that is unknown. Therefore, in case of non-concurrent forces, along with magnitude and direction, we have to determine the position with respect to fixed point. To determine this position, we are using the Varignon's theorem of moment. Varignon's theorem क्या होता है कि just like concurrent force system, number of forces are replaced by a single force called as a resultant. But here system is non-concurrent, and that's why here moment comes into account. Okay, so simple theorem है Varignon's theorem of moment. It is simple theorem. ये तीनों forces का जो भी moment होगा O point पे, that should be equated to moment of resultant about the same point. Okay, so moment of all the forces in the system about any point. Suppose I am taking moment of this 10 20 10 about O, ये तीनों का जो भी moment होगा, that moment must be equal to moment of their resultant about same point. ओके, सो कैसे भी किया तो सेम ही होगा, वो रिजल्टेंट क्या होगा, तीनों फोर्सेस का सेम होगा. It states that sum of moment of all the forces forming a system about any point is equal to moment of their resultant about the same point. यानी कि तीनों forces का जो भी moment होगा about वो point, same moment will be there of their resultant about the same point. Same thing I have written over here. Summation of MO means moment of all the forces about O point will be equal to moment of their resultant about same point. So resultant is 20 Newton. So what will be the moment about O point of these forces? तीनों forces का moment क्या होगा? This 10 anti-clockwise about O, so 10 into 2 plus this 20 into 4 minus this 10 into 6. Why minus this 10? Because this is rotating clockwise and these two are rotating anti-clockwise. Okay, so minus 10 into 6. So that will be the moment about these three forces about O, and moment of resultant about the same point means what resultant R is 20, so R into A. So we'll assume that distance as initially what we'll do, we'll draw one line, show R here at a distance A or X, whatever you want to assume, you can assume that X or A. So moment of these forces will be equal to R into X or R into A. Okay, by solving this, here only is unknown. Solve this, you will get distance x or a from origin O. That is nothing but the location of resultant. We have calculated that by using Verignos theorem. Okay, so this is the use of Verignos theorem. If you replace these three forces just by this system, here if you show instead of R 20 Newton and this distance is 2 meter instead of A, calculated distance. So effect of these three forces about point O will be same effect of this resultant R at a distance 2 meter from O. So that is nothing but the Wegener's theorem. Okay. Now next term is equivalent force system. So what is equivalent force system? Equivalent force system is what? Here you can see here equivalent force system here it is remove this force. Now see, initially using Verignos theorem, what we did here, this 10, 20, 10, these three forces we have replaced it by a single force of 20 Newton at a distance 2 meter. Sometimes even there is a question, replace this system by equivalent force system. अगर मुझे ये जो system है इसको भी equivalent force system से replace करना है तो क्या करूँगा मैं? So wherever I want to replace it, I will remove this 20 Newton from here and I will replace that force here. Suppose I want to replace this 20 Newton force by equivalent force at O point. So what I will do here, I will replace this force, means I will remove this 20 Newton from this point and I will act at O point. See this particular point. मैंने क्या किया है, ये जो फोर्स है यहाँ से रिमूव किया और अगर मुझे O पे रिप्लेस करना है सिस्टम तो मैं क्या करूंगा, आई विल रिमूव दिस 20 फ्रॉम हियर एंड आई विल शो इट एट O पॉइंट. ओके, 20 Newton, but its effect, rotational effect, it causes the rotational effect, its effect should be same on the body. To show the same effect on the body, what I will do, I will take its effect at this particular point. तो इफेक्ट यानी कि क्या, उसका मैग्नीट्यूड तो मैंने रिप्लेस किया है लेकिन इसका मोमेंट प्रोड्यूस होगा 20 न्यूटन से अबाउट हो, तो मोमेंट क्या होगा, दिस 20 into 2 रोटेटिंग एंटी क्लॉकवाइज, 20 into 2 will be 40 Newton meter, that I will show with this arrow, anti-clockwise arrow like this. Okay. Now this is called as equivalent couple or equivalent force couple system. Okay, so there are so many examples of equating. Even many times it is asked to replace these three forces by equivalent couple system. यानी कि उसका रिजल्टेंट निकालना है, उसको O पे रिप्लेस करना है या राइट साइड पे रिप्लेस करना है. Wherever you want to replace it, you can replace it. Now in this way, in this case, what I did, I removed this 20 Newton from this point and I have replaced at O point. Means 20 मैंने यहाँ से रिमूव किया और O पे दिखा दिया है, देखो यहाँ पे. और उसका मोमेंट भी मुझे, उसका इफेक्ट बॉडी पे आना चाहिए, तो क्या करना है मुझे, जब मैं यहाँ से रिमूव करके यहाँ पे रखता हूँ O पे, तो आपको करना क्या है कि 20 into 2 will be the moment at O point. It is in anti-clockwise direction. So 20 into 2 is 40, rotating in anti-clockwise direction. That must be shown about O point. So at O point, don't show only 20 Newton magnitude, but also show this 40 Newton meter anti-clockwise moment. Suppose instead of O, it is asked to replace this 20 Newton at right side at this particular point on right side here. So what I will do, I will remove this force from here. I will show here that force and then I will take moment of this 20 about this O point by taking this perpendicular distance. Suppose it is 1 meter, so 20 into 1 it will be clockwise. Now I will show, I will instead of O, what I will do, I will show that force here 20 Newton and it is rotating clockwise, so I will show clockwise movement of that particular force. In this way, convert a given system into a given force couple system at a point. Apply a single force at that point and couple at the same point. The single force is the resultant of the force system and couple is the algebraic sum of moment of all the forces about the point. So this is called as the replacement of a given force by a couple system. Okay, so this is about the equivalent couple system. Okay, so we'll see few examples in next lecture about the equivalent force couple system. See what we learned today. We have learned about equivalent force system. We have learned about Verignos theorem. Verignos theorem का use क्या है? To locate the resultant within the body of the non-concurrent force system. So उसका statement क्या है? The sum of moment of all forces about any point, यानी कि जितने भी forces का उसका moment about any point equal to moment of the resultant about same point. So we learned about Verignos theorem. So we learn about resultant of parallel forces, upward positive, downward negative. We just add the forces, you will get the resultant. Then we learn about the couple of the force system, properties of the couple. So this is most important for exam point of view, couple system. Then we learn about the moment of a force. Okay. So I think this is sufficient for today. So I will stop here. Okay. So during the lecture, I will solve few more problems. Okay. Thank you. Thank you very much. Have a nice time.